Good afternoon, and welcome to the Center for Sustainable Materials Chemistry's webinar on Postgraduate Career Strategies in National Labs. This is part 2 in this series, and my name is Blake Holman. I will be your moderator for today's webinar. Today's webinar is part of an ongoing series of innovation webinars put on by the Student Council for Innovation, which is a student and postdoc-led team within the center. Our mission is to help build a bridge between academia, CSMC research, industry, and national labs. Some of our learning objectives for today is how a graduate student or postdoc can prepare for a career at a national lab. Can we gain information from our panelists on what it is like to make this transition from being a graduate student or postdoc to working in a national lab setting? And some of the decisions you may have to ask yourself when you consider a career in a national lab. We are joined today by 3 guest panelists. We have Monty Helm from Pacific Northwest National Lab, Mark Allendorf from Sandia National Labs, and Ashe Huck from Oak Ridge National Lab. Each of our panelists have spent a number of years working as research scientists at these labs, and it is a great opportunity for us to have them here with us today. Before we start the general questions, I will ask that our panelists give a brief bio about themselves. So Monty, if you'll start us off.
You bet. Thanks, Blake. So I got my bachelor's degree at a smaller undergraduate school in Minnesota, Minnesota State University at Moorhead, after which I went to the University of Colorado at Boulder, where I got a PhD in inorganic chemistry. I did 2 postdocs following that. One of them was a research postdoc at the University of Sussex in Brighton, and then I did a half-time teaching, half-time research postdoc at the University of Tennessee. After there, I went to an academic position at Fort Lewis College in Durango, Colorado, where I was for about 10 years, 9 or 10 years, on which I got my staff position here at Pacific Northwest National Lab. So I took a little bit of a different route to a staff position at a national lab and go directly out of a postdoc. And here we're currently working on electrocatalysis for renewable fuels. Thanks.
Thanks, Monty. We'll move on to Dr. Ashe Huck from Oak Ridge National Lab. Ashe, if you could give us a quick introduction.
Like Monty, I also started out at a small liberal arts college in Massachusetts, where I had a double major in physics and computer science. From there, I went on to doing a physics PhD at Stony Brook University, and most of my research was done at Brookhaven National Lab, where I worked at the National Synchrotron Light Source. I got my PhD in 2003, at which point I moved to Argonne National Lab and worked at the Intense Pulse Neutron Source. And then from there, I got a staff position at Oak Ridge National Lab to build and essentially run the science program on the powder diffractometer at the Spallation Neutron Source. My research interest essentially is technique-based, so I do structural work using powder diffraction, but primarily working on electrochemical processes like battery materials, solid oxide fuel cell materials, and a little bit of catalyst materials as well.
Thanks, Ashe. And we'll now move on to Mark Allendorf from Sandia National Labs. Mark, if you could give us a quick introduction.
Sure. So I'm a senior scientist at Sandia in Livermore, California, and I've been here for a little over 29 years. I came here straight out of graduate school. I did my undergraduate work in chemistry at Washington University, and then I went to first MIT for a short stint, and then my thesis advisor was bought out by Stanford and moved the whole research group to the West Coast, and that's where I finished my PhD, which is in inorganic chemistry. I first worked at Sandia in the combustion research facility, which is a DOE user facility, and then moved into a variety of other areas at the labs, and I'm now working on some supramolecular materials called metal organic frameworks that are nanoporous.
Thanks, Mark. And lastly, my name's Blake Common, and I'm a third-year PhD candidate in the Department of Chemistry at Washington University in St. Louis. I received my bachelor's degree from Blackburn College in 2010, and I completed a master's in organic chemistry from Southern Illinois University in Edwardsville in 2012. I currently work for Sophia Hayes at Washington University, where my research focuses on solid-state NMR characterization of inorganic metal oxide precursors and their corresponding thin films. We'll now move on to the general questioning, but before I move forward, I want to tell you a little bit about the format for today's webinar. The general questions, each panelist will have 2 questions to respond to. This is a 1 to 2 minute response, and we'll cycle through the panelists until the general questioning is finished. And then I'll open the webinar up to a live Q&A with the audience. For the audience members that are just joining us, in your control panel, you will see a dialog box for questions. If you'll type your question into that dialog box, I will try to ask as many questions to our panelists as the time allows. And then finally, the panelists will summarize some key points and provide a take-home message, and we'll conclude the webinar. Our first question goes to Monty Helm. How do the hours compare to being in academia? So we're really wanting to know what's your general day like? How many hours do you put in?
Yeah, that's a good question. I would say that, it's cyclical, and it definitely varies, between the time of year and when you have funding for projects and all that. But generally, I guess what I would say is that how you spend your time changes. It's always I think generally being a scientist, you always put in more than 40 hours a week, and we expect that of our postdocs, and our staff do also. But I think it becomes, it shifts as you go along in your career. So when you're a younger staff member here, you're definitely in the lab more, you're pushing the chemistry yourself, you're hands-on. Then as you go along in your career, you end up spending more time in your office, which probably a lot of us don't like that. We would rather be in the lab, but it just becomes you end up doing more writing and working more on proposals. So same amount of hours, but it shifts. One of the differences, I would say, though, at a national lab compared to being in academics is that you aren't married to the academic schedule. In academics, typically you have some teaching responsibilities, or you'll have responsibilities when graduate students are starting, at certain times of the year. That's just non-existent at national labs. So it's much more flexibility in the schedule as far as taking vacations and not being present. Thanks.
Thanks, Monty. Our next question is for Ashvia. Ashvia, grad students and postdocs typically travel quite a bit to present their research. Do staff scientists and research scientists get to travel much to conferences?
Yes, I would definitely say that's actually one of the more important things to do, travel, especially for somebody like me who's at a user facility, because we are somewhat in the business of providing a service to the scientific community as a whole to come and do their experiments at this user facility. So we find that a large number of people are unaware of all of the cool stuff that you can do at national labs. So we travel quite a bit. I go to anywhere between 3 to 4 conferences a year. Foreign travel is a little bit harder, but domestic travel we definitely do quite a bit.
Thanks, Ashvia. Our next question is for Mark. Mark, you mentioned last time in our previous webinar that national labs employees are government workers, some national labs are government workers and some are not. How is being a contractor different from, say, a government employee?
Right. So maybe I should start with sort of a definition of what a national lab is. And from the government's point of view, what that basically stands for is a Department of Energy laboratory that is run by an independent contractor. So this could be a company. So for example, with Sandia, it's Lockheed Martin, or it could be a university. For example, Lawrence Berkeley Lab is run by the University of California. So that's in contrast to what are designated federal labs with a capital F. Federal labs would be like the National Institutes of Standards and Technology in Washington, D.C. The people who work there are actually U.S. government employees, whereas DOE National Lab employees work technically for the contractor, although it's a little ambiguous. At Sandia, there's something called Sandia Corporation, which is neither Lockheed Martin nor the government. But in any case, we're essentially non-governmental contractor employees, and all of our benefits and HR policies and that sort of thing are those of Lockheed Martin. So we have certain benefits that are things like 401k and retirement support that are actually negotiated when the contract for the laboratory is set. And there are some differences between what our benefits are and those of Lockheed Martin. And I guess I'd have to say that the best way to say all this is that it varies from laboratory to laboratory, and what specifics have been negotiated between DOE and the contracting company. From the point of view of your daily life, I don't think it's really all that different whether you're at a federal lab or a national lab, except that the big federal labs like NIST get their money either from a government department like the Department of Defense, or directly from Congress like NIST, which is part of the Department of Commerce. So in principle, they are essentially 100% supported by federal money and do not typically write proposals to other agencies, although they can and do. So that's the difference. I know that sounds a little complicated, but that's the way it is.
Thanks, Mark, for clarifying that. Move on to our next question for Monty. Oh, go ahead. Sorry.
No, go ahead.
We'll move on to our next question for Monty. Monty, some national labs are probably concerned with productivity. How do they measure their productivity? Is this by the number of publications, or is there some sort of internal standard?
Yeah, good question. I'm happy to talk about that. It's complicated is the short answer, and very dependent on what particular project or group you might be working in. So for example, here at Pacific Northwest National Lab, you could end up in sort of one of three categories. So if you're in the fundamental sciences, like our group is, then the answer is, yeah, largely your productivity is measured by the publications, but not just the number, but also the quality, and it's a combination of that. And what they look at is sort of a combination of your citation record over time. So, over the past 3 years, have you been publishing articles that have been cited by others in the field? Are you starting to be recognized as a leader? And so it's a combination of both the number and the quality. There's something called an HI index that PNNL uses, which is a measure of sort of your impact as a scientist. So that would be something that you could look up if you're interested in learning how that's sort of a combination of quantity and quality. If you are in the Energy and Environmental Directorate, they're more on the applied sciences side, and they'll look more at patents, transitions from science into technology. So that their measure of productivity is a little bit different. And there's still fundamental science being done there, but it's definitely more applied science towards having a product coming out in the end. And then there's the National Security Directorate, where publications and patents are not what they measure, and because what they're working on is probably very sensitive information. And so their productivity will be measured more on if they're making their clients, whether it's Department of Defense or Department of Energy, if they're hitting their metrics for what their projects are expected of them. So that's somewhat of an ambiguous answer, but sort of sums up the 3 different levels here at PNNL, what people are measured by for productivity.
Thank you, Monty. Our next question is for Ashvia. Ashvia, we had several people ask in the last webinar, what does a typical work week look like for you? And an example was, what are the differences between a typical research lab and, say, a user facility?
So there are different types of user facility, but the type that I work in, which is essentially a scattering facility, it's a neutron scattering facility. Previously, I've also worked at a synchrotron facility. The difference between these scattering facilities compared to, let's say, a nanocenter is that we actually have a 24/7 operation. So it's fairly expensive to make X-rays and neutrons using these accelerator facilities. So when we're operating, we are operating essentially continuously for a certain number of days. So at the Spallation neutron source, we run for 200 days out of the year. So for example, so the work week really depends on the type of job you do. If you're an instrument scientist, typically an instrument will have multiple instrument scientists, so we essentially take turns in covering users. The distinction between most other employees in the National Lab and the user facility folks like us is we are often on call. So if something breaks in the middle of the night because X-rays and neutrons are so expensive, we actually have to come and fix things. But that's not typical. That is more rare. But generally, 1 week, for example, last week I put in probably close to 60 hours, but I handed over the beamline on Monday, and this week I can go home whenever I want. So it really varies depending on whether you're local contacting or not.
Oh, that's great to know. Thanks, Ashvia. Our last general question goes to Mark. Mark, how is hierarchy established for each research group or funded project in a national lab? I know we kind of touched on this maybe a little bit last time, but if you could follow up with it.
Well, I can explain how it works at Sandia, and I think it's probably a little bit different at some of the other labs, but Sandia operates a little bit more like industry. We have a management ladder and a technical ladder, and the management people do not do any research, or very little. Whereas some other labs, there may be people who are so-called group leaders who maybe have a management role and a research role. That's not the case at Sandia. So people can wear a lot of different hats, and the hierarchy kind of depends on the sorts of projects that you work on. So as an example, we have a lot of work at Sandia that involves nuclear weapons. That's our main line of business, actually. And those are very large projects. So there's an entire vice president who's in charge of that work, and under him are multiple organizations and let's see, I would say 1, 2, 3, 4 levels of management. So the lowest level of organizational structure at Sandia is called a department, and that typically has between 10 and 20 or so members, staff members, could include postdocs, contractors, other kinds of people like that, and that's headed by a department manager. The department manager reports to a senior manager who maybe has 3 to 4 departments under him, and then that person reports to a director who again has some senior managers, and then on up finally to the VP. So if you're a hands-on person or a research person like myself, you would report to a manager at some level. Now I'm fairly high in the ladder, so I report to a director. Most people, most staff member would report to a department manager, but they would probably manage their own projects pretty much on their own. So in many cases there are PIs, principal investigators, who bring in their own money or get the money from some other large project, and they're designated as the responsible person for managing that money and seeing that the work gets carried out. So the distinction is basically between programmatic type leadership, which a PI would be considered, and what we call line management. And line management has the responsibilities for things like performance review, salaries, anything to do with HR, usually the safety and environmental health responsibilities, those sorts of things. But people who are managers, line managers, can also be program managers. So it can get pretty confusing at times. I think from the point of view of a person entering the lab and wanting to do research, you would probably expect, no matter what lab you're in, to be in a relatively small group, probably no more than about 20 people, and you would report to a single manager who would be responsible for you in this line capacity. So I hope that sheds a little bit of light on that murky subject.
I think it does. Thanks, Mark. This will conclude our general questioning, and we will now move on to the live Q&A. Just to remind the audience who joined us a little late, if you would like to ask a question, please type your question into the chat dialog box or the question dialog box on your control panel, and I will try to ask as many questions as possible in our allotted time period. One of the first questions that came into us is if someone secures independent funding while doing a postdoc in a national lab, can the individual embark on an independent research project that is not in alignment with the mission statement of the national lab? So I think I'll pose this question to Monty. And Monty, if I need to repeat the question, I can do so.
Yeah. It's a good question. I think from my perspective, the easiest answer is no. But if I could just back up one step, you probably wouldn't have been allowed to apply for that funding in the first place. And so we have to, as Mark was saying, when we are looking at funding, we have to go through our line manager. And there, on some proposals, are a limited number of proposals that the labs can submit. And so it's internally competitive to first present your idea to then get approved to apply for external funding. So there's a couple layers of administration between you and funding here at PNNL that would prevent that situation likely from ever occurring. So that's the short answer. It might stem other questions, but maybe other folks can add to that.
Yeah, Ashe or Mark, do you have anything to add?
I would say I think at least in Oak Ridge it's the same as Monty said, that in order to acquire funding you have to go through the lab internal process. However, that's not necessarily true for collaboration. So for example, what can happen is if you collaborate with an external PI, they could station a postdoc. That's true in where I work, is they could essentially come up with a memorandum of agreement that they will station a postdoc to do some of their research work at the national lab. That is possible, but getting funding is, you have to follow the procedures.
That's pretty much true at Sandia also. We do have maybe one exception. We have a kind of super postdoc level, which is called a Truman Fellow, and those people come in with money given to them by the lab to do independent research, and I believe that they can certainly apply for other kinds of internal research money, maybe outside funding as well, but I'm not completely sure. The thing about postdocs is that, at least at Sandia, they're not viewed as permanent employees, and there has to be somebody on the hook at the laboratory who has long-term responsibility for meeting the needs of some particular sponsoring agent or agency, and that's why postdocs typically do not apply for their own funding.
Thanks everyone for the answer. answers. Our next question is kind of a continuance from our last webinar. Do the national labs support visa applications for international students for both postdoc and staff scientist positions? Ashvia, I think you might be the best one for this question.
Right. So as Mark just said, postdocs are not considered staff members. So generally, national labs do not support the immigration. They can write letters in support of the application, but they will not do the funding for it. So you have to hire your own lawyer to apply through the system. However, staff scientist is different. My entire visa process was done through the lab. The lab has a company that they subcontract, and that company, the legal firm, does everybody who's a foreigner their paperwork, and including permanent residency. This is how I actually got my permanent residency, which was through the lab.
Thanks, Ashvia. Our next question is, how easy is it to transfer between national labs as a career move? Monty? You answer.
Yeah, that's a good question. I think that as far as like culture-wise, I think that you have a little bit of an advantage as far as you have a little bit more insight into the landscape of how national labs function, and you may be familiar with DOE. As far as actually doing that, I think it really would depend on if you have a need that a different national lab is really trying to fill, and there may not be a place for you at the current lab. So for example, if for some reason I was a beamline expert here at PNNL, it would not be that great for me to be here because we don't have a beamline, so then it might be easy for me to transfer someplace that does, if that became a large part of my research program here. But other than that, I think it would be hard to just say, oh, I'd like to live, in, Tennessee, so I want to transfer to Oak Ridge and just try to make that jump without there being a specific scientific need for that. I'm not sure if that answers the question, but that's the best I got.
Thanks, Monty. Mark or Ashvia, do you have anything to add?
I think Sandia would be the same. There's a little bit of a difference in that Sandia has multiple sites. So our main laboratory is actually in Albuquerque, New Mexico, and there is movement between the California site where I am and New Mexico. Not on a really high frequency basis, partly because people moving from one city to another means they have to buy a house or rent or something like that. So it's a significant career change even though you're staying within the same organization. But the National Lab system is really a network of independent laboratories that cooperate when it's convenient, I guess would be the best way to say it. I mean, there are formal collaborations, but we're not under an umbrella where you're considered an employee of the National Lab system. You're an employee of the individual lab, and so going from one lab to another would be essentially like going from one company to another.
I would just add that in the user facility, it's not very common, but there are people who move from facility to facility. So for example, when the spallation neutron source started up, a large number of our instrument scientists were hired from either national labs or international labs. So we have a whole collection of people who came from either Argonne National Lab or Los Alamos National Lab. So when a new facility is built, you have to these are very focused jobs, so there are very few people who are trained to do them. So there is some movement, but generally it happens when a new facility is built. So we expect that some of our colleagues might eventually want to move back to Europe where they're building the European spallation source, but that's 10 years down the line. So that's a small movement, but there is some movement there.
Great responses, everyone. Our next question, in our last webinar, it was mentioned that postdocs, except special named postdoc positions, are not often hired on as permanent employees. What is the most common route for people to become permanent employees? I think we'll start with Mark.
Well, I guess I would say the most common route is that a person, if they're at the PhD level, would be hired into a specific staff job that would be advertised to the outside world. At Sandia, these days it's pretty customary that people are hired after they have already done a postdoc if it's in a physical science like chemistry or physics, where that's more customary. In other fields, maybe computer science, for example, where there's a lot of demand, that may not be the case. People might come to Sandia and be hired straight out of graduate school. So Sandia does hire people who have been postdocs, convert them to staff. In fact, there are 3 of my postdocs where that happened. But Sandia, if you ever ask them, a manager or something like that, they would tell you that there's no policy or no understanding that a person who's hired as postdoc would be considered as a staff member. Now, I should let my colleagues here on the phone comment, because I know the other national labs do things a little bit differently.
At Oak Ridge National Lab, I believe the general procedure is that when a staff position opens up, the internal postdocs are also considered candidates if they want to apply for it. But just like Mark said, it's not postdoctoral job itself is not considered permanent staff position until they're converted, which generally requires an interview process.
Yeah, I agree. That's the way P&L happens too. When we advertise a staff position, it's competitive with external folks. I think the only advantage that our postdocs have, besides knowing the group and the people and we knowing them, is that they know that the job is posted, typically right when it is posted or around the same time. So, whereas it might be harder to catch that externally unless you're checking for the ads and having a connection to know when those positions open up.
Thanks, everyone. Our next question, some national labs work closely with universities and colleges. Can one hold a joint position with a university or a college while working as a staff scientist or research scientist? Maybe we'll start with Monty.
Sure. The short answer is yes, but again, I think that it has to be driven at some level where it's advantageous for both of the institutions. So here at Fort Lewis, we have a couple joint appointees. They're typically more senior staff that have gotten brought in as national lab employees, where they already have an established group outside. And so there's some advantage for tying in the research that they're doing at the university with their particular skill set that we want to expand into here at the lab. As opposed to, I don't know too many staff members or any that I'm aware of here where they started as national lab employees and then became joint appointees with an institution. And I'm definitely not aware of anyone that was hired into that sort of situation. So to sum up, I guess the short answer is yes, but it's typically established academics that are brought in and given a joint appointment as a research staff member here at PNNL.
Ashvia, is it the same for Oak Ridge as well, or?
Oak Ridge actually has, the state of Tennessee has something called a governor's chair. That position generally most of the time has a joint appointment where they are also faculty members at UT Knoxville. And just like Monty said, these are generally people because they're getting a governor's chairship, which means they are fairly senior in their careers, and this is the lab and the university is trying to attract them to come and establish their research program in both the facilities. There is, however, certain national labs, and I know that that's true in Brookhaven, has an adjunct appointment with Stony Brook. So essentially that there is no money changing, and you essentially the thing that you get by being an adjunct faculty member is you can recruit graduate students to come to work with you, provided you can afford their salary. So that system also exists between UT Knoxville and Oak Ridge National Lab, where we have certain staff members here who are adjunct in the sense that they don't have to teach or they don't get paid out of the university, but they can become supervisors for graduate students.
Interesting. Mark, how does Sandia work as far as the joint positions?
Well, the New Mexico laboratory is fairly closely associated with the University of New Mexico. So there are a few individuals there who have these joint appointments, and I believe the way they work, at least in some cases, is that the university pays half the person's salary and Sandia pays the other half. And the advantages are that the Sandia staff member can hire graduate students and can actually apply to some funding agencies that the national labs do not typically have access to. An example would be the National Science Foundation. Here in California, there have been joint appointments in the past. I'm not sure if anybody has one right now. Of course, we have a lot of universities in this area. I do know that Lawrence Berkeley has some pretty tight connections with the University of California, and in fact, in certain areas like materials science, materials chemistry, the people who are LBL staff there are actually all joint appointments with the faculty, and nobody is hired into those positions. You have to be a faculty member first, and then you, by definition, become a joint appointment with the Lawrence Berkeley lab. So that's a very close relationship. I don't know of other labs that do it quite that way.
Well, thanks for the input there. Ashvia, I'll direct this next question towards you. What does the current job market look like at national labs, particularly for government positions? And what do you recommend is the best way to break into that job market? Is it through usajobs.gov or networking?
Okay, so again, very few jobs at National Lab is government jobs. So just like Mark mentioned, NIST is the only lab that I know of which is a directly government lab. There might be a few others. We're mostly contract employees. And the best way, first of all, I would say that it helps in being having some connections in the national lab. So if you know people, that's always good. Or if your work is known by people who work at the national lab, you can make the connection that way too. The jobs are posted, but as in any job, if there is a connection that somebody actually knows of your work, that of course helps in getting the job. So in principle, we post all our jobs and we look at all the applications that come in that have the necessary qualifications. But what puts you above other candidates is your reputation, which means essentially what have you published, how well your work is cited, and you know, we also get recommendation letters from people that you've worked with. So we use all of that information to judge if the candidate is suitable for the job or not.
Monty or Mark, any additional comments?
No.
Yeah, I thought that was great.
Okay, we'll move on to our next question. What kind of competition is there between scientists and the staff within a certain division of a national lab? And maybe Monty, you can lead us off on this question.
I think Ideally, the people that are hired into a certain group, like Mark outlined at the beginning, usually our group is around 20, so under a certain particular line manager. The idea is that you should be working together, and the degree of competitiveness, I would say, generally isn't or shouldn't be very high. Now, of course, things become challenging when funding is limited, and so people are out sometimes hustling to try to find projects to work on, and it can be competitive sometimes to find coverage if when times are tight. But that isn't necessarily a bad thing or a negative competitive, negative competition. It's more just everyone trying to find out what's best and how to fit in. So I would say generally, at least my experience here has been that it's not a highly competitive environment when it comes to making progress in the science. For sure, it's more of a cooperative.
Thanks, Monty. We'll go on to our next question, and I'll read it directly as how it was stated in the chat. I have been seeking a long-term position at national labs for around 10 years, yet the overwhelming number of positions which are offered are for project scientists, i.e. undergraduates, graduate students, and postdocs. The few positions which I see offered do not seem to be in chemistry, specifically organic chemistry. Can you please make a statement about the number of future openings for long-term positions in organic chemistry? And Ashvia, maybe you can start us off.
Unfortunately, my knowledge about organic chemistry is next to nil. I am a physicist by profession, and most of what I do is hard matter, so it's inorganic chemistry. So I'm afraid I don't really know what the answer to that question is.
Monty or Mark, do you have any thought or comment on this?
I can try to give an answer. I think, unfortunately, I think the question is accurate as far as the observation is that those positions tend to be very limited. And largely it's because the national labs are typically DOE or DOD sponsored, and so they're really looking at energy applications or defense applications. So organics, straight organic synthetic chemistry is going to be very limited as far as usefulness, as far as a skill set at a national lab to apply to lots of different projects. And all that being said, we do have some organic light-emitting diode projects here, and I know that there's a lot of organic atmospheric chemistry. And then other than that, there's some ligand syntheses that we do, but typically we don't look for organic chemists with the background because it's more about the metal coordination and the catalysis. So I think the question, like I said, is valid and probably truthful in that those positions are very limited and hard to find.
There are certainly some organic chemists at Sandia, and I think a lot of them have backgrounds in polymer chemistry. But as Monty mentioned, there are other areas where organic materials are used where an organic chemistry background would be valuable. I guess I would say that it's just a matter of timing. At any one time at Sandia, there could be, I don't know, as many as 100 or more staff positions that are posted, but they're all over the map. I mean, everything from from electrical engineering to math to chemistry. So one shouldn't necessarily be discouraged. I think again the trick is not to go hunting on the website looking for something that seems to be a match. As Ashia said, the best thing to do is to make a connection with somebody and find out where your skills might be most applicable, and then try to get your foot in the door that way.
Thank you, everyone, for your comments. Our next question is, what is the typical career development as a researcher? As a scientist gets older and maybe less intellectually competitive, what are the possible career options for that researcher? Monty, maybe we'll start you off with this.
Yeah, I would say, well, first of all, typically the older established scientists, at least here at P&L, are not considered, necessarily intellectually less competitive. In fact, since they're established, they tend to have a higher degree of maintaining their funding. Of course, they're then less hands-on in the lab with their projects, and they become more of a managerial position. Now, all that being said, though, a lot of senior scientists here do sort of transition away from doing science, and oftentimes will pick up some management duties or some leadership positions, which are less scientifically driven. So, yeah, I would say as you proceed in your career here at the National Lab, if you aren't staying in the hard sciences, like Mark outlined at the beginning, you really need to move into the management track to maintain a longer-term career here if you're not going to stay active as a scientist.
Ashvia, is it the same way at Oak Ridge?
It is a little slightly different in that we can also do both science and management work together, unlike what Mark described in Sandia. So I'm actually the group leader for the diffraction group, and I also support beamline here. So there are 4 beamlines in my group. We all work together. So this is really a personal choice, whether you want to go into any of the management roles or you want to just stay in the science role. So we have essentially 6 grades of scientists. You start as a junior scientist, and the highest that you can achieve is what is called a corporate fellow. Those are very few. We, out of the 4,000 people who work at Oak Ridge National Lab, we probably have about 20 corporate fellows who has achieved the highest level of recognition as a scientist in their own fields. So it's really a personal choice whether you want to combine management, do only management, or do both.
Thank you, Ashvia, for the extra input. Since we're starting to run low on time, I'll go ahead and move on to our next question. And Mark, you've already kind of touched on this with the Truman Fellowship, but that was kind of for a super postdoc position. Do the national labs award any fellowships to incoming postdocs? And are any of these applicable to foreign nationals?
Well, the only thing that Sandia has that is a fellowship specifically is this Truman Fellowship that I mentioned. And that's a specific application process that's conducted once a year, and it's intended essentially to be a way of recruiting top-notch scientists and engineers to the lab. So it's very competitive. They only interview about 5 or 6 people and maybe award 1 or 2. So it's a pretty exclusive club. So being hired as a postdoc doesn't mean getting necessarily a fellowship like you might be thinking of, let's say an NSF postdoctoral fellowship. Now that said, it's possible to apply for agency-sponsored fellowships. DOE has several of them, for example, and a person who's a postdoc at Sandia could apply for one and be supported by it. Most people who come here as postdocs are supported under 1 or more projects. When I have postdocs, I have a couple of them right now, I try to keep the number of projects they work on to no more than 2, occasionally dipping their hand into a 3rd one. And that's just out of consideration for them that they be able to be as productive as possible. But they're working for whoever my funding sponsor happens to be, just like I am, and have objectives that I as a PI would set, and then we work together as a team to try to achieve them.
Thanks, Mark. Monty or Ashvia, do you have anything to add?
Oak Ridge has a few more fellowships, but you have to apply for those fellowships. I think we have about five named fellowship, and often it's not just applying for the fellowship. You also have to identify partner organizations, so some division inside the lab who you're going to come work with, because some fraction of the funding actually comes from the lab and some fraction comes from the division who you're planning to work with. So there are 5 fellowships, but other than that, the only things that I know of are the early career awards from DOE that one can apply for if they come in as a postdoc and they decide that they want to continue working here, and that's one funding mechanism. If they get an early career award, that's a 5-year funding, and they can continue working with that funding within the lab.
Yeah, I agree with Ashe and Mark. PNNL only has one named fellowship, unfortunately, the Linus Pauling Fellowship for Postdocs, but the mechanisms that they described are almost exactly the same here. Thanks.
Thank you, everyone. We have time for maybe 1 or 2 more questions. I guess our next question would be, are there any Department of Energy or Department of Defense grants that are only awarded to scientists at national labs? And Ashe, maybe I'll let you start this one off.
Yes, I guess that would be us, because there aren't any other neutron facilities running in universities, so there is only one DOE-sponsored lab right now that hosts a neutron facility, so this is a very unique grant that we have, which allows us to run as a user facility, but we come under the same sort of BES user facility, so while we're the only neutron facility, the same group of people also manages all the synchrotron facilities and also the nanocenters, but they generally tend to be big grant for these specialized projects. I am not sure about how the other projects work, whether they're you have to be a national lab employee to apply for those or not.
Thanks, Ashe. Our next question, is it easier to get funding for research at a national lab than in academia? And I think I'll direct this towards Monty.
Yeah, that's a good question, and again, probably a complicated answer. I would say it is more competitive here to get funding as an individual PI with sort of your own independent ideas. So that's really specific, but it's comparing to what you would do as a professor in an academic situation. You would apply to NSF or DOE for a single investigator grant. What the national labs do have that are a little bit different, though, are sort of large funding pools that they can use from DOE to hire scientists to work on projects. So, coming in as a young staff member, typically you'd be, at least here, you'd be hired in and asked to work on projects that are already funded. And then as your career progresses, then look towards getting some funding to continue your own area of research within the mission of the group. Whether it's the early career grant from DOE, like Ashe mentioned, or some other funding. But those tend to be competitive. So like I mentioned earlier, if you want to apply for a DOE career, we only as a lab, I think here at PNNL, let 3 to 5 of those go out a year. So you have to compete internally first. Yeah, challenging to get individual funding, but there is more group funding opportunities, I think, in national labs, at least here at PNNL.
Thanks, Monty. We're starting to run low on time, so I would like to take the remaining time to allow our panelists to give a short 1 to 2 minute take-home message. Ashe, if you'll start us off.
Well, I think the science career in national labs and academics is similar but different. In terms of doing the scientific activities, they're probably not very much different, but there's no tenure track process in most national labs. There are a few which has the same process, but also there is no tenure track jobs in national labs. So essentially, we do get, once in a while, we get furloughs where the labs have to reduce their staffing. And at that point, generally, what is looked at is how well funded you are and how well recognized you are. But overall, it's essentially a great job to have. And if you enjoy doing science, everybody should look into what are the possibilities that can line up with your scientific interest, if that's in a national lab or in the academics.
Thanks, Ashia. Mark, we'll let you go next.
Yeah, I guess I would add to that just by saying that the national labs, you know, however many there are of them, 9 or 10, are really very diverse places. Some are very large, like Sandia, which has over 10,000 employees and does a lot of almost everything. But some are a bit more specialized or have specific customer sets. A good example of that would be the National Renewable Energy Laboratory in Golden, Colorado, which does almost exclusively renewable energy related research. So it would be a good idea to investigate these individual laboratories to find which ones are you know, best aligned to what your interests are. I would say that the labs in many ways offer a great sort of middle ground between academia and industry. We don't always do as much basic research as universities, and we don't have students, so teaching is not a responsibility. But on the other hand, there's a lot of application-oriented research that ties directly into some very important real-world problems. So if it's important for you to have an impact on something that you really can see directly, I think national labs offer a lot of possibilities.
Thank you, Mark. And we'll finish with Monty. Monty, if you could provide us with a quick take-home message.
I think along the same lines, the way that I view this position as a whole since I've been here is that it kind of hits the middle ground between an academic position and an industrial position. So, you know, as Ashvia pointed out, we don't have tenure, so we do have to get funding, but we still do basic science, at least we do in our group. And so that's maybe a little bit different than industry. So I feel like our jobs are a little bit more secure because if where companies will become, you know, your job can be dependent on if the company is profitable or not. The DOE labs or the national labs, I think, have a little bit more stability as far as their long-term presence in the nation. So yeah, it's kind of that middle ground. You do have, you don't have to do the teaching, so you have a little bit more time to do science, but you don't have the freedom to explore all the science that you want. It has to be sort of in line with the mission of the group that you're hired in. At the same time, you're not as subject to changing the whims. If a certain product line in industry isn't working, they'll typically cut it off and ask you to do something else. Here you have a little bit more control on finding promising directions. So yeah, I think for those interested in a career in a national lab, that's a good way to think about it, sort of that middle ground between academics and industry. Thanks.
I would like to take this time to thank you, the audience, for joining us today, and our guest panelists, Monty Helm, Ashvia Huck, and Mark Allendorf, for giving us insights into the National Lab. I would also like to thank the members of the Student Council for Innovation who helped put the webinar on today, Lauren Fulmer, Zaid Ma, Ryan Frederick, Ryan Manser, and Betty Maddox for helping prepare the webinar. If you enjoyed today's webinar and would like more information on future webinars, please visit us at sustainablematerialschemistry.org or follow us on Facebook, LinkedIn, and Twitter. Recordings of today's webinars are also made available on our website. If you have any follow-up questions for our panelists, they have agreed that you can contact them through us. So if you have any questions, please go to our website and send us an email, and we'll direct those questions to our panelists. Again, thanks for joining us today, and have a great afternoon.